So say in order summary network 155.1.0.0 here in EIGRP it is also available. I mean it is also possible to configure wildcard mask, whereas it was not possible in RIP, right? And we were also having some disadvantages in RIP, like because wildcard mask was not there, right? Like if let's say that we were having a router and we wanted to enable RIP, then it was also possible that RIP was enabling on some of the interfaces unnecessarily. However, we didn't wanted to enable RIP onto those interfaces, but still RIP was getting enabled onto those interfaces without any reason, right? So even it was not possible to fix this problem over there in RIP, right? But in EIGRP that is possible, because in EIGRP we can configure wildcard mask. So here you have that option, like you can say 0.0.245.245. However, again here I'm not going to specify this wildcard mask, right? And then I can go for network 150.1.0.0, because what does it mean? That it will be taking it on class full network, right? Class full boundary. So which means that EIGRP will get enabled onto all those interfaces which are having an IP address from the range of 150.1.0.0/16. And also EIGRP will get enabled onto all those interfaces which are having an IP address from the range of 150.1.0.0/16, right? So finally I'll copy this configuration and paste on all other devices. Like here I'm having R2, then I'll move on R3, then I'll enable it onto R4, then on R5, then on R6, on switch 1, on switch 2, on switch 3, and finally on to switch 4. And because they are all of them, I mean all devices in this network are having an IP address either from 155 subnet, I mean 155's network or 150's network. That is why EIGRP will get enabled onto all devices now. Even you can look at switch 4. This time switch 4 must be able to see all routes in its routing table. You can look at this 150's range 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10 networks, all 10 lane networks are available in the routing table of switch 4. So EIGRP D, which means EIGRP AD value 90, this is metric, right? I have already shown you that how can you look at the topology table, like there was R5 and if you want to see neighbors, right? EIGRP neighbors, right? If someone asks you that, okay, how will you verify that EIGRP neighborship has came up successfully or not? So you will be looking at queue count. If this queue count is 0, which means your neighborship has came up successfully. If there is any value in queue count, whether it is 1, 2 or 3, whatever it is, if there is any value under queue count, which means that your neighborship haven't came up yet, right? Haven't came up successfully. So this is the way to look at the EIGRP neighborship, that whether it has came up successfully or not, right? So you will be looking at queue count only. If there is any value rather than 0, which means that EIGRP neighborship has not came up successfully. Is there any problem now? Fine. नहीं सर, फ्लैपिंग के केस में नहीं होता. नेबरशिप एक तरफ से लर्न हो गया, दूसरी तरफ लर्न नहीं हुआ. और भी बहुत सारे रीजंस होते हैं. एक्नॉलेजमेंट नहीं आ रही तो क्यू काउंट बढ़ता है. मेनली क्यू काउंट तभी बढ़ता है जब एक्नॉलेजमेंट नहीं आती. फाइन. सो queue count is 0 for all neighbors, which means neighborship has came up successfully with all neighbors. Hold down timer by default it is 15 seconds in EIGRP. Then you can look at uptime. Uptime shows that from how long neighborship is up, right? And SRTT is smooth round trip time, which tells you that what is an average time to reach neighbor and come back, right? That's why I'm calling it round trip. That's why we are calling it round trip, right? So SRTT is there, and this is retransmission timeout, RTO. RTO will always be higher than SRTT, and RTO value will always be depending on SRTT. As you can look at this, that if SRTT is lower, RTO is also lower. If SRTT is higher, then RTO is also higher.
6 times.
Right? Yes, it is 6 times to the SRTT. So RTO will always be 6 times to the SRTT, and hopefully you have understood all these things now, right? That what is the meaning by Q count, RTO, retransmission timeout, which means that, for an example, we transmitted an update packet towards our neighbor, or query or reply, whatever it is, and we didn't get an acknowledgement within 486 milliseconds, which means that it will retransmit that information after 486 milliseconds. That's the meaning by RTO, retransmission timeout. So this RTO timer will be in use whenever you will not receive any acknowledgement in the response of either update, query, or reply.
So RTO will be activated after every 486 milliseconds?
Not after every 480 milliseconds.
Like if I'm not getting
RTO will get activated immediately just after sending any packet out from either update, reply, and query. Right? So if you have transmitted an update packet towards your neighbor, then it will immediately activate its RTO. If it does not get an acknowledgement within RTO, then it will retransmit that packet.
So we can say that if we are not getting the acknowledgement of any update, then after each 486 seconds,
it will retransmit that. And one more thing, that this RTO will start to increasing if it is not getting an acknowledgement, because SRTT will get increased automatically in that case. Hopefully you have understood it. And what is the meaning by hold down timer here? Like if it does not receive an acknowledgement within the hold down interval, then it will break neighborship. That's the meaning by hold down interval. Have I taught you that how to configure authentication in EIGRP?
yes,
I think so. I have taught you, right? Then I have also taught you that how to change timers like hello interval and hold down interval. Yes, I taught you. Because in previous class I taught you stuck inactive, and to prove that I changed hello interval and hold down timer, right? So we have covered all those things. Now again I will start with from very basics. Let me tell you the uses of passive interface. Now you know very well that how can you define passive interface in EIGRP. Still I am using classic mode, right? So router EIGRP 100, then I'll be saying passive interface, and if I say default, which means that all interfaces will become passive interface. All of them will become passive interface. If you want to configure any single interface as passive interface, then you can define passive interface, fast Ethernet 0 by 0, something like that. Usually you will be using passive interface default command, right? So what is the meaning by passive interface in EIGRP? It will stop sending hello packets. It will stop sending hello packets to out from that interface which has been configured as a passive interface by you, right? So if you configure any interface as passive interface, then it will immediately stop sending hello packets out from that passive interface. Understood?
yes.
Fine. So this is passive interface, default command is there, and then you can say that no passive interface, fast Ethernet 0 by 0. So what will happen? What will be an advantage of using this command? Because of course you will require to send hello packets of EIGRP out from very specific interfaces, right? Or out from very limited interfaces, but might be that you will require to enable EIGRP onto multiple interfaces, right? So let's say that you have enabled EIGRP onto all interfaces, onto all layer 3 interfaces available onto your switch. Now let's say that onto some of the interfaces our lane users are connected, right? We are having so many lane facing interfaces in our network, right? So after enabling EIGRP onto all those interfaces, EIGRP will start sending hello packets out from those interfaces by which your lane users are connected, right? However, it is not necessary for EIGRP to send hello packets out from those interfaces by which your lane users are connected to your router, right? To your layer 3 switch. It is not necessary, because it is never required to send hello packets towards lane users. Hello packets will be required to send in that condition only where you are having your EIGRP neighbor. If there is no EIGRP neighbor connected onto an interface, then there will not be any advantage of sending hello packets. But you will definitely require to enable EIGRP onto those interfaces if you want to advertise those prefixes into EIGRP. So to advertise prefixes into EIGRP, it is mandatory to enable EIGRP. Now if you enable EIGRP, then it will start sending hello packets out from those interfaces. Now what I want to advertise prefixes into EIGRP, and also I don't want to send hello packets out from the lane facing interfaces, right? So I will be using this passive interface command, because if we enable passive interface command onto any interface, now you must be knowing or you must remember that after enabling passive interface, it will stop sending hello packets, but still it will keep on to advertise that prefix into routing table, right, in EIGRP. So that's the uses of passive interface. Fine. So in this way you can configure passive interface. After going through this passive interface, I think I have already taught you variance, right? The uses of variance. I taught you unequal cost load balancing, right? Fine. After that, let's go for equal cost load balancing. Let's go for equal cost load balancing. Yes. So now I'm going to perform equal cost load balancing, and it is pretty easy. Show IP route. Let me show you topology table. Show IP EIGRP topology. This is the topology table, and by looking at topology table, we can see that for the loopback of R1, this is R1, and this is we are on R5, right? For the loopback of R1, R5 is having successor and feasible successor. So this time is working as a successor, and this lane, I mean this link is working as a successor. Take a feasible successor. So one is successor, another one is feasible successor. So this time what I want, I mean my requirement is to perform equal cost load balancing for this prefix onto these two interface, I mean onto these two neighbors. I mean for these two neighbors I want to perform equal cost load balancing for the prefix of the lane of R1, for the lane prefix of R1, right? Hope you understood it. I mean you have understood my task. In routing table, it is having only one path available in its routing table to reach 150.1.0, that is via 45.4, which means via R4 only. But in topology table, so IP EIGRP topology 150.1.0 and then its subnet mask. So you can look at this, that it is having like via 45.4, which is successor, via 25.2 as well, which is possible path this time, and via 35.3 as well, which is working as a feasible successor. Fine. Now I wanna force my R5 to perform equal cost load balancing only for the lane prefix of R1. So you know very well that via successor it is having lower metric, via feasible successor it is having higher FD, higher metric. Via successor it is having lower FD, via feasible successor it is having higher FD, feasible distance, higher metric. So because you know, in any routing protocol it is not possible to reduce your metric. You cannot reduce your metric, but definitely you can increase it with the help of offset list. As you used offset list in RIP, similarly you can use this offset list in EIGRP2. So first of all, let me move on to R5 now, and let me tell you the difference actually in between the metric via 45.4 and via 35.3. So this is the metric, right? So that is let me show you, that is 2374 and then 656 minus because it is lower, right? That is 3456, right? 3 4 5 6 51200. This is the difference actually in between the metric of successor and feasible successor. So now if I add this much metric via successor, then the metric of successor and feasible successor will become same, and then you know very well that all routing protocol supports equal cost load balancing. So you will see that R5 will start doing equal cost load balancing, right? So let's move on to R5 now and let's perform this practical now. So access list and permit. First of all, in AC you have to call that prefix for which you want to change your metric with the help of offset list. So that is 150.1.0 and then it's wildcard mask. Fine. Then you will move into EIGRP 100. Then you will say offset list. AC number was 10 in because this prefix is in inbound prefix. Then offset how much? 51200, right? That was the difference. Now we want to add. We can press enter over here as well, but again your result will remain same because we wanted to add that this much metric 51200 for the prefix for the lane prefix of R1 whenever it will be received on R5 as 0 by 1 only. So I'll configure this R5 in this manner so that it will get changed, or it will change its metric. It will add metric 51200 in the lane prefix of R1 whenever it will receive that prefix onto R5 serial 0 by 1. So I will be saying serial 0 by 1. So just after doing this configuration, now you will see that R5 will start doing equal cost load balancing. So let me show you. Show IP route. This time for the lane of R1, it must perform equal cost load balancing, and you can see, you can look at this output that it is performing equal cost load balancing only for the lane prefix of R1, right? And via both neighbors, now its metric has become same. So if metric is same, then definitely all routing protocols will perform equal cost load balancing. And this time it is performing equal cost load balancing just because of your maximum path value. Show IP protocol. By default, your maximum path is configured as 4 in EIGRP. If you say router EIGRP 100, maximum path is 1, then after you will see that it won't be possible for EIGRP to perform equal cost load balancing onto this router R5. So now you look at the routing table of this router, you will see that it won't be possible for for R5 to perform equal cost load balancing for the loop back of or for the lane prefix of R1, right? So this time it is not performing that, and still its best path is via 45.4. Right? In this case, if now you could ask Mr. how it has elected this path, or how it has installed this path only in its routing table via 45.4. Why not via 30? I think it's 35.3, right? Why not 35.3? So its answer is very simple. Whichever path will get installed into routing table first, it will remain there. Whichever will get installed in its routing table, then it will remain there, or it will be preferred, right? So that's the logic behind it. Okay, fine. Once again, router EIGRP 100 maximum path, let's say once again it is 4. So what does it mean? That now it can perform equal cost load balancing among 4 paths for the lane of, for all received prefixes actually, right? That's the maximum limit. But if you wanna configure, let's say that you wanna configure higher than 4, then it can go up to 16. But in latest iOS, sometimes it will go up to 48, and sometimes it will support up to 64 as well. Maximum path, right? So this time it's maximum path. Let's say by default it is 4, and this time you will see that once again it will start doing equal cost load balancing. One more thing, in EIGRP you are not going to use this offset list just to perform equal cost load balancing. Even you can use this offset list to manipulate your path selection. It is not always to you to say that you will be using equal. You will be using equal cost. You will be using this offset list to just perform equal cost load balancing. Not at all. I will never say like that. I will simply say that offset list is used in EIGRP just to manipulate the metric. That's it. That's the only uses of offset list. So remember that we will be using offset list just to manipulate metric, right? Now by manipulating metric, you can perform equal cost load balancing, or you can also manipulate your path selection. Let's say that I just want it because by default for R5 its best path was via R4 to reach the lane prefix of R1. Now I wanna do some configuration so that for R5 its best path to reach R1 will become via R3. So you can add some more metric over here, like you just added only 51200. Add one more 0. Now you will see that its best path will become via R3. It's not it. The best thing about this offset list is that you can manipulate metric for that prefix for which you wanna change. It's not like variance. Variance was configured globally.
Variance is effective on all.
It's not it. Variance is always configured globally. So according to the requirement, I'll be using either variance or offset list. But remember, with the help of offset list, you cannot perform unequal cost load balancing. With the help of offset list, you cannot perform unequal cost load balancing. Yes, you can perform equal cost load balancing, but without variance, it's not possible to perform unequal cost load balancing. Once again, I'll move on to R5. Router EIGRP 100, I'm gonna remove it. And once again, it will be in its default state. Once again, its best path to reach the lane of R1 will become via 45.4. Fine. So that's the uses of offset list. But remember, with using offset list, you cannot perform route filtering here in EIGRP. In EIGRP, it is not possible to perform route filtering with using. You can perform only and only path manipulation. Variance done. Passive interface is also done. Now we covered offset list. Then after it, let's go for administrative distance value. Before metric, it will always compare administrative distance value. And one more thing, offset list can be configured either in inbound direction as well as in outbound direction. Let's say for R5, its best path to reach lane prefix of R1 should be via 35.3. So let's do one thing via, because before metric it will compare its AD value. So via R4, let's define its AD value as higher than 90. So we can change it, we can modify its AD value, and it's very simple. Like first of all, do show IP access list. Yes, in ACL we have already called it, right? So now move into EIGRP router mode and then say distance is what, 91, and then IP source address is what, 155.1.45.4. wildcard mask, because this is a single neighbor, and then ACL was 10, and then enter. So it will change its AD value as 91 whenever it will receive that prefix from its neighbor 45.4. Yes, I configured ACL 10. Now you can look at this, that its best path is become via 35.3, because before metric it will always compare. So it has proved that before metric it will always compare its AD value. So via 45.4 it was having higher AD value because it was 91, whereas via 35.3 its AD value is still 90. So it is preferring now AD value, lower AD value. Fine. So in this way it is possible to change AD value. Now if you wanted to filter it out from its routing table, right, you can also do that. First of all, let me remove it from here. I'm removing it completely from here, no access list, that is 10. So let's move on to switch 4 now. Same as RIP here, in EIGRP2 we can perform route filtering with using AD value like this. Route to EIGRP 100, distance EIGRP, then for internal routes it's 245, then for external prefix let it 170. For internal prefixes it has been configured as 255, for external it is still 170. Show IV protocol, you can look at here. There is no route available, right? So in T-shoot they can also do this. Then they can also perform it for a single prefix. Let's say I want to do it for the lane prefix of switch 3. Which is 9.0, right? So I'll be seeing access list 5 commit 150.1.9.0. Sorry, then go to EIGRP 100, distance 245, then source address 155.108.8, its wildcard mask, and then ACL number, that is 5. Then in place of 245 make it 90, and then you will see. So you are not required to remove it, right, permanently. You can modify its AD value. In place of 255 you can set its default AD value, that is 90. You can see that 9.0 is available now in its routing table. Fine. AD value is done now. Let's go for summarization. In EIGRP, summarization is same as RIP. Like you can do summarization, you can configure summarization anywhere in the network, right? And also there will not be any routing loop. Like in RIP it was possible that routing loop could occur, right? But here in EIGRP there is no possibility of routing loops occurrence, right? Like this time what can we do? We can move on to switch 3 and we can advertise these loopbacks in the range of 90s networks. Then router EIGRP 100 network 90.1.0.0.0.0.7.255. So you will see that EIGRP will get enabled onto only those loopback interfaces which are having an IP address from this range, right? So only on 7 loopbacks EIGRP will get enabled, and even you can look at this output. So it has been enabled onto all loopbacks, right? But if you create another loopback 8 90.1.8.1, you will see that EIGRP will get not enabled onto this loopback. Is EIGRP enabled onto this interface now? Tell me. So this is the uses of wildcard mask in EIGRP, right? सेल फोन बैग में रख लो, पीछे मत देखो, मैं हूँ बोलने के लिए. Fine. So in this way we can advertise prefixes into EIGRP, and then finally you can look at switch 4. You must be able to get all those prefixes available, you see. So all of them are available here in the routing table of switch 4, which means that all those 7 loopbacks have been advertised into EIGRP, but that loopback 8 is still not advertised by EIGRP because we used wildcard mask. If it was a RIP, then it was, RIP could have enabled RIP process onto loopback 8 as well, right? So this is the difference with using wildcard mask and without. This is the difference if you are using network command with wildcard mask and without wildcard mask. So that's it. Next is summarization now, because we know very well switch 3 is advertising all these prefixes individually on /24. So we want that switch 3 should advertise it summary prefix only. So it's very simple. You can move on switch 3, router EIGRP 100, and then sorry, interface F0 by 0, summary address EIGRP mod IP summary address EIGRP 100 or field 90.1.0.245.248.0, right? So that will be your summary address for all these 7 prefixes. Now all 7 prefixes will be suppressed within this summary address, right? So you will see that switch 3 will advertise only and only this summary address, right? And it is not like RIP, that in RIP this information was converging. It was taking so long time actually to converge properly, right? but this time you will see that EIGRP will converge quickly. So this time you can move on switch 4. On to switch 4, you will see that it will not receive any single prefix individually, and it will be receiving only and only summary address. Right? You can look at switch 3's routing table. As I told you that in EIGRP, whenever you will configure summarization, it will always put that entry in its local routing table towards null 0. So you can look at its own routing table, and you must be able to find that entry, and its AD value will always be 5. So IP route 90.1.0.0 fine. So its AD value is now 5. Do not think that in EIGRP AD value of summary address is 5. It will be 5. It will be 5. Of course, we know that, okay, for summary address it is 5, but only on that router where you configure summarization. Only for that discard route, its AD value will be 5. If you look at any other routing, any other router, like let's say that you moved on to switch 4 and then you are looking at this summary address, then you will find that its default AD value will be, because AD value has local significance. It will never be carried forward within EIGRP updates. Understood? So this AD value 5 is there. You can look at switch 3, and I'll let you know that why is it necessary to configure its AD value as 5. Don't worry about that. So this time we configured this summarization, but as you must knowing that summarization is just not used for reducing total number of prefixes in routers routing table. We can also use summarization to perform path manipulation, and I'm gonna to do that now. Interface F0 by 0, just remove this command from here. You will see that once again this switch 3 will start advertising all these prefixes individually on /24. Now what I want that for this entire network, for all routers, their best path should be by R6 only to reach these 90s prefixes. So what can I do? On to switch 1 itself, on its F0 by 1, here I can configure summarization. It will advertise only and only summary address, so that now even for R3 itself, its best path to reach all these 90s prefixes will become via R6, because via R6 they will be receiving all these prefixes individually, right? So now you can look at, or you can do configuration at the end of switch 1, F0 by 1 IP summary address EIGRP 100, and then it will be once again this switch 1 will add this entry in its local routing table towards null 0 interface, right? And you know what is the advantage of this entry? Now if switch 1 gives this summary address to its neighbors R3 can advertise it towards R1, then R1 can further advertise this towards R6, and then R6 can advertise it back towards switch 1. So this time switch 1 is not gonna to accept it. You know why? Because switch 1 is already having that same prefix in its local routing table. However, prefix length is same, like switch 1 installed summary address in its local routing table towards null 0, and also it is receiving that summary address coming from R6. Same prefix with same prefix length, right? But you know very well that if prefix length is same, then it will be comparing their AD value. So for this discard entry, for this null 0 entry, by default EIGRP's AD value is what? 5. Whereas whenever this switch 1 will receive this prefix coming from the direction of R6, then its AD value will be 90. So which AD value will be preferred? 5. So you can see that switch 1 is still receiving, because if you look at R6 routing table, so you can see that it is receiving this via R1. So definitely, because R6 is receiving it from R1, then R6 will forward it in the direction of switch 1. But switch 1 is not gonna to accept it. But in RIP, it was accepting that, right? But here it will not accept it by default. But if you want to accept that prefix via R6 itself, you do one thing onto switch 1. As you configure this command over here, just remove it and once again configure it. And because you can specify your AD value as well, make it. And if you want to make it 2 for 5, then this null entry will never be added into the routing table of switch 1. This null entry will never be added into its routing table. So you will see that routing loop can occur in your network now. This null entry is still there, so run interface F0 by 1. This time null 0 entry is not there. I'll show you /21. R6 is receiving it from 67.7 itself. How? Fine. R1 146.6. Here it does not have that prefix, that assembly prefix, but still it is giving. Just wait. Fine, this time it has received it from 146.1, right? And now you will see that it will start advertising this prefix in the direction of switch 1, and then switch 1 must receive it from, you see, 67.6, and then R3 is still receiving it from switch 1. So in case now if switch 3 is any one of the loop back, goes down, and then on to switch 4, which is a trace route 90.1.1.1. So routing loop can occur if you configured summarization and if you modified an AD value of summary address. To solve this issue, once again move on switch 1 from F0 by 1. As you configured here summary address, make it what? 5, and once again you will see that there will not be any problem. So clear IGRP neighbors. Right. So now on to switch 4, you can try to ping with it. You will see that it will be dropped by 37.7. You see, because null 0 entry is there now, so there will not be any routing loop. After 8, we can also use this summarization in EIGRP for the purpose of load balancing. Right? What I want that for first 3 prefixes 90.1.0/24 to 90.1.3.0/24. This path YR3 and then switch 1. This must be preferred for all routers in the network, right? But for all remaining 4, what?
एक समरी की स्टफ इंटरसेक्ट जी और पे डाल दी और इसको ये समरी को डाल दें.
Exactly. What will I do? As I said that for first 3 prefixes, this link must always preferred. So which means that on to switch 1's F0 by 0, I will summarize all these first 3 prefixes, right? Let's do that. So interface F0 by 0 IP summary address for first 3 90 sorry right, then F0 by for last 4 prefixes. After doing this configuration, on to switch 4, you can trace route 90.1.1, which means it should go by R3 itself. Okay, which means that this prefix is not up. We can move on, switch 3, and we can say no, shut down. You see, it's not it, it's going via 35.3 from 3 to directly from R5 to R3 and then directly to switch 1. But if you trace route 4.1, 45.4, 146.6 and 67. Which means it is going in this way. So it has proved now. Apart from it, you could also do fine. After it, there is one requirement actually. What I want that we must, from switch 1 I must advertise only and only summary address, but along with that what I want that for this prefix 90.1.5.0 only, for this prefix, see I wanna do configuration in that manner, in such manner, so that switch 1 must advertise only and only summary address towards rest of the network. But along with that I also want that for this prefix only all these devices must prefer this link, this one in between R3 and switch 1, for this prefix only, right? And in case if it goes down this link, then they should be able to reach this prefix via R6. Exactly. So what can we do here on switch 1? You see, I can create one access list. Access list can permit 90.1.5.0, then its wildcard mask. I'll create one route map with the name of leak permit 10, match IP address 10. So whichever path, whichever prefix will be permitted within this ACL will be permitted by this route map as well. So just come outside, then go to F0 by 1, say IP summary address EIGRP 100 and 90.1.0.0 to 255.2 for 8.0, and then lake map name is this command I configured on F0 by 1, whereas on F0 by 0 I'll be configuring it without lake map, so that out from F0 by 0 it will not advertise this prefix individually on /24 itself. Right? So now you do one thing. From switch 4 for 5.1 you must go via, you see 35.3, 37.7, right? And we can try to trace route 90.1.1 as well. So it is also going via this one only, because might be R3 is preferring this path only, right, for even for summary prefix, right? So I just wanted to tell you that we can also use lake map. Even you can look at the routing table of R3. Along with summary address, it is also receiving this prefix individual. Done. So this is the uses of link map along with summarization. Fine. Then let's see that how can we change, how can we modify k values. But remember that if you are changing k value on one router, then you have to modify it onto all devices. Router EIGRP, I'm starting it from switch 4. I just wanted to change metric weights 0, that is toss, and then k1, k2, k3, k4, k1 0, k2 0, k3 1, k4 0, k5 is also 0. You show history. Now you will see that it will break neighborship. So now says R5 is having neighborship with R2, R3 and R4, but it is not having neighborship with switch 2. So you do one thing, just copy paste configuration. Now it will form, R5 will form neighborship with switch 2, but will break neighborship with all others. Any problem in it? So in this way we can modify these k values. Right? Let me tell you that how can you configure PBR. Let's say for R5, if you look at its routing table, best path to reach the loopback of R1 is via 45.4. Let's say I wanna forward this traffic in the direction of R3 only. So on R5, I can say access list 101 IP, permit IP when source is any, destination is right, and then I can configure a match IP address, set IP next hop, and next hop is 155.1.35. Then go to F0 by 0 of R5, right, and then I can say IP policy route map, then route map name is, that's it. Now whenever it will receive any packet onto this interface in source, whatever it is, and if destination is 150.1.1.0, then it will forward those packets in the direction of R3. However, according to the routing table of R5, its best path is via 45.4. But if you trace route now from switch 4, trace route 150.1, from where it is going 35.3.
And sir, if anyhow serial 00 is down in that case,
then there will be a problem. One more thing, if serial 00 down, then it will not forward this traffic into the direction of R3. But what if in case from R3 it is not reachable? Right? So second. Have you understood it now? And I think in CCNP you learned about reliable policy based routing. Like R5 should configure its next hop as 35.3. In that case only if this destination is reachable via R3. Let's say that from R3 if the loopback of R1 is not reachable, then R5 will still forward this traffic into the direction of R3. And one more thing, with the help of PBR you can also create a routing loop. Like what will I do now? I will move on to R3. I can create one another access list 101 permit IP when source is any, destination is 150.1.1.0, and then wildcard mask, then route map name is PBR loop, and then I can say match IP address 101. Then I can go to S0 by 0 and then I can say, oh my god, I didn't configure next hop, right? So I'll say IP set IP next hop is 155.1.35.5, right? So it will forward this packet back towards R5. Are you getting my point? Fine. Now you see I have configured it, right? So I'll move on S0 by 0. IP policy route map name is PBR loop. Done. One more thing I would like to show you here. Still there will not be any loop. You know why? Because whenever packet will move towards R5, R5 will receive it on F0 by 0. Here I configured PBR, right? It will switch it into the direction of R3. R3 received it on S0 by 0. Again I configured PBR. It will forward that packet into the reverse direction, right? Into the direction of R5. And remember that split horizon rule doesn't apply for data. Split horizon rule applies only for your routing updates in RAID and EIGRP. It does not apply for your data, real data. So this time R3 will forward this data back into the direction of R5, but onto R5 says 0 by 0 there is no PBR. There is no PBR, so it will perform simply routing lookup, and then R5 will forward this traffic into the direction of R4. Even I can show you that, okay, your traffic will move into this direction now. You see? Great. First of all, R5, R3, and once again R5. So R5 given traffic to R3, then R3 gave this traffic back to R5. But again, R5 has given this traffic to R4 and finally R1. Because onto R5 says 0 by 0, there is no PBR. Do one thing, create one another route map, test, permit 10, match IP address 101, here ACL 101 was already there, set IP next hop 155.1.35.3, and this time there will be a routing loop, you see, onto switch 4.
So you have applied it already?
On R5s. Okay, on R5s. Okay, I haven't applied it yet, right? On interface S0 by 0. IP policy route map and name was and this time there must be a routing loop. So with the help of PBR, remember that there can be a routing loop in your network. So be aware with all these things if you are going to configure PBR in your network. A big problem can occur after configuring PBR in your network. Right? So do one thing, go to S0 by 0, sorry, on R5. Go back to R3. Remove it. This time it will go, your traffic will start from switch 4 and then it will directly go into the direction of R3, then switch 1 and then R6 and then finally R1. In this way, switch 4, switch 2, R5, R3, switch 1, R6 and R1. Right? So basically PBR is used to manipulate your routing tables decision. So if you want to manipulate your routing tables decision, in routing table it was saying me that okay, its best path to reach this destination prefix is via R4. But with using PBR I configured it that okay, if this is source, this is destination, then your packets will be forwarded into this direction. Right? So that's called PBR. This is not reliable PBR, right? This was only and only PBR. Then do you know that how to perform redistribution into EIGRP? That's very simple, right? Fine. Let's move on to switch 3. And you know very well that in EIGRP 100 I advertise these networks, right? I'm going to remove that. Show IP. What will I do now? I'll configure another process of EIGRP, that is 1000. Node assembly network 90.1.0.0. Show IP EIGRP interfaces. So EIGRP 100 and 1000. So now you know very well that by default in EIGRP routes, prefixes can move from one process to, from one AS to another process without redistribution. So now if you want to advertise all these prefixes from AS1000 to AS100, then we have to perform redistribution, right? To do that, router EIGRP 100 say redistribute EIGRP 1000. It is not mandatory to specify this time matrix, because prefixes are coming from EIGRP and also moving into EIGRP. So matrix will remain same. So remember that if you are redistributing EIGRP into EIGRP, then you are not required to specify your matrix during redistribution. Done. So you can simply say redistribute EIGRP 1000. Now you must be able to see them onto switch 4 as external prefixes. Let me show you. Yes, but the point is I think I have configured summarization somewhere in the network. So onto switch 1, onto its F0 by 1, let me remove it. Fine. So you will see that all of them will be advertised now individually as external prefixes. And by default their ready value is what? 170. Fine. In EIGRP during redistribution, we can also add tag. To add tag actually during redistribution, and if you wanna redistribute some specific routes only, let's say I wanted to redistribute from 1 to 5 only, right? So I can say access list 50 permit 90.1.1.0.0 then 0.0.3.245, and then in it itself I'll be saying 4.0, and then I can take 1 and then 245, which cover 4 and 5 both. So in very first command I have taken from 0 to 3, I mean 1 2 3. In next command I have permitted 4 and 5 because I wanted to permit only from 1 to 5. I don't want to allow 6 and 7 to get redistributed into EIGRP. Have you understood it or not? Because with using a single command it is not possible to match 1 2 3 4 5 only, and if you are doing that with using a single command, then 6 and 7 will be covered automatically. So now you do one thing, say route map redistribute from EIGRP 1000 to EIGRP 100. Permit match IP address, that is 50. I created access list with number of 50. In route map I have permitted only those prefixes, right, which are permitted in an ACL. And then apart from that I can also say set tag. Let's say you said or 900, right, from switch 3. And then after you do one thing, go to router EIGRP 100, say redistribute EIGRP 1000, and then after I can say route map name is, you can copy and paste it, right, and that's it. Now you can look at switch 4 and you will see that only 1 to 5 prefixes will be there, right? And then you can try to open this prefix 90.1.1.0 245.245.245.0. You can see its tag value, that is 900. Apart from it, you can also do one more thing, show IPICRP topology 90.1.0, then its subnet mask, and you can look at its topology table as well. So it is also containing some external data in which it is having originator router's router ID. So originator's router ID was switch 3's router ID, and that was by default 155.1.9.9, and AS number of route is what, 1000. Action protocol was EIGRP. We didn't redistribute it from BGP into EIGRP or from RIP into EIGRP or from OSPF into EIGRP. We redistributed from EIGRP into EIGRP itself. And then administrator tag is what, 900. We configured it. So in this way you can perform this redistribution into EIGRP. So you can redistribute only selected prefixes, right, with the help of route map. You can define tag value with the help of route map. You can also redistribute RIP into EIGRP in this manner. Let's say on R6 we are having some what बेनिफिट क्या होगा वो आगे बता दूंगा, टेंशन क्यों ले रहे हो इतनी, अभी तो बस बता रहा हूँ कैसे ऐड कर सकते हो.
We cannot redistribute the specific prefix in the RIP in the same manner like we are doing.
We can do that. I told you that we can use route map in RIP as well during redistribution, and in RIP in fact we can use route map at the time of redistribution only.
Okay.
There is no other spot in RIP to use route map.
Okay.
And we can also add tag over there.
Yes.
Fine. So on R6 now I'm gonna to add some loopbacks once again. Loopback 1, and then let's say 60.1.1.1, and then one more loopback, and here let's say 60.1.2, then loopback 3, and only 3 loopbacks are much enough. Router RIP version 2 node assembly network 60.0.0.0 because it belongs to class A and we cannot use wildcard mask. So this single command will work fine. And then after, because by default these prefixes will not be moved into EIGRP domain, right? So we have to redistribute them from RIP into EIGRP. So we can say router EIGRP 100, say redistribute RIP, right? But at that moment you have to define your metric, because by default metric of RIP is what? Hop count. And this time you are redistributing them into EIGRP, and in EIGRP its metric is bandwidth, delay, load, reliability, and all these things, right? So during redistribution it will be mandatory now to specify your metric whenever you are redistributing any other routing protocol into EIGRP. So RIP metric, then it will ask for bandwidth. Let's say by default we are considering bandwidth as 10,000, and then delay is like 10, reliability is highest, load lowest, MTU 1500. Fine, that's done. If you do not want to specify your metric over here, then you could say default metric 10,000, 10 to 5, 1, and 1500. You could also use this command. If you are using this default metric command, then at the time of redistribution, then you will simply require to say redistribute RIP or redistribute OSPF. You understand? Yes. So this time you are using default metric, right?
So what is the default value of the default metric?
That we defined over here.
Like if you are not defining
Then nothing. It does not use any default metric. If it was using default metric, then we would have not required to define these values during redistribution.
Like, so if we are not defining these values, then our
Your redistribution will not be performed,
okay.
because it does not have any default metric. Whereas OSPF has some default metrics like 20. When we redistribute anything into OSPF, then by default its seed metric is what? 20. So in OSPF we are having default metric, but we do not have such options available in EIGRP as well as in RIP. If you are redistributing anything into RIP, then again you have to define your metric. Then, so in this way you can use your metric along with the redistribution command, or you can also specify your default metric. After it, along with this redistribute to RIP, you could also use route map, where you could define your tag value. You could redistribute selected routes, right? You could match your prefixes to whom you wanted to redistribute from RIP into EIGRP. So it will be depending on you that what do you want to perform here in this environment, right? Finally, on stage 4, I must be able to see all of them. So yes, all 60 prefixes are available. So EIGRP topology is 60.1.1.0/24. You can see that this time external routing protocol will be RIP, because we redistributed this prefix from RIP into EIGRP. So this external data will always be carried forward within EIGRP updates. Remember that this external data will always be carried forward within EIGRP update. Then what is the uses of it? I'll be discussing it in next class now, right? In tomorrow's class. Now, apart from it, you can also look at its routing table onto switch 4. Show IP route 90.1.0. All these routes are coming after crossing hop count value, hops 5. All these prefixes are coming after crossing 5 hops, right? Now by default your maximum hop is what? Maximum hop count. Show IP protocol, it is by default 100 in EIGRP. Let me show you show IP protocols. Yes, by default hop count value is what? 100. Now you do one thing, say router EIGRP 100, and then say metric maximum hops is what? 4. So what does it mean? That it can accept only those prefixes which are coming after crossing maximum 4 hops. If any prefix is coming after crossing more than 4 hops, then it will never install all those prefixes in its routing table. In T-shoot they can do this, right? So this time you can look at this output. So it will be having only these prefixes. So it does not have 90s prefixes as well as the lane of like 150.1.9.0. Lane of is 3, because all those prefixes are coming after crossing 5 hops, and this time this device is not going to accept any one of the prefix which is coming after crossing more than 4 hops. So if any prefix is coming after crossing 5 hops, then definitely this switch 4 will simply discard all those prefixes, right? So this is the meaning by maximum hops. Understood? So now we have covered all the basics of EIGRP. Then in next class I'll start your like some advanced topics of EIGRP, like route filtering, and after route filtering I'll go for stub routing, then I'll perform default routing, and apart from that, as I told you that in EIGRP we are having some advanced features now in named mode, like we are having add path, we are having FRR fast reroute. So I'll be configuring all those features in EIGRP named mode, right? So I'll start all these things in next class now. That's enough for today. Just try to revise all these topics by today itself, so that you will not forget these topics. Show IP protocol, once you will configure, see guys, once you configure show IP protocol commands, it will show you maximum hop count, right? And this time it does not have all those prefixes. If you want to receive them, say maximum hop count, once again it is 100, it can be maximum up to 255. So once again you will start to receive all those prefixes here. Let me show you. All those 90s prefixes are available now. Fine.